All right, then on to the next fun part of graphing trig functions, the vertical and the horizontal translation. So, once again, you start with the basic graphs of sine and cosine. Vertical translation would mean it gets shifted up or it gets shifted down. Horizontal would mean it gets shifted to the right or shifted to the left. Let's take a look at an example. Number 1. So we'll just start off with sine, and then what if it was x minus pi over 2? Now it may not be obvious when you look at this to see that shifts it to the right, but it actually shifts it to the right. So first of all, y equals just sine of x. So graph it without the pi over 2 to begin with. This should go from 0 to 2 pi. This should be pi over 2. And then the y values from -1 to 1. Okay, so this is just sine of x as, you already know, see? It's on the graphing calculator right there. Okay, now next to that, and I want to make this one blue. What if you do sine of x minus pi over 2? And then compare the two of them. So this red part right here got shifted over to the right. And it got shifted over by pi over 2. Because right here is pi over 2, and right here is pi. So this got shifted over to the right. So even though it says minus pi over 2, it's actually shifting it to the right. Then, just real quick with a piece of scratch paper, let me explain why it's shifting to the right when it seems like it should be shifting to the left. Let's do a little bit of pre-calculus first. So this is y equals x squared, which makes a parabola, and the vertex is right here at 0, 0. Okay, then what about x minus 2 squared? So since it says minus, it seems like it should shift to the left. Well, where's the vertex? For this one, the vertex is at 0, 0. That means that the y value equals 0. And if you plug in that right here, then you'll find out that x equals 0. What about for this one? So when does it hit the x-axis? Is it over here at positive 2 or is it over here at negative 2? Well, whichever one it is, if it's here, y equals 0. And if it's here, y equals 0. So no matter what, I can plug in y equals 0 and then solve for x. Take the square root of both sides, it's still going to say 0 equals x minus 2. And right here is the reason that even though this says minus, it shifts it to the right. Because the next step is add 2 to both sides, which means you're doing the opposite. And so x equals a positive 2 is where the vertex is. So even though that says minus, it actually shifts it to the right. Okay, so enough with that scratch paper. Now for this one. So we're going to have in total 4 things. 2 of them are about the x-axis and 2 of them are about the y-axis. So I'd like to start organizing that. Here's the x information and here's the y information. So x information, or in other words, the x-axis information. One thing is the period. And for sine, the period is 2 pi. If there was a number in here other than 1, then I would need to divide by that number. But this is just a 1, so 2 pi divided by 1, it's still 2 pi. And then this is going to be shifted to the right, so that's called a vertical translation. It's also called the phase shift. And you could either write that it's a positive pi over 2, or you could even emphasize by saying to the right. Now for the y information. So the number in front right here, that gives you the amplitude. And in this case, it's a 1. And then there is the vertical shift. And this one does not have any vertical shift. So if this said +7 right here, or if it even said 7 plus sine, then it would be a vertical shift of 7. But this, the vertical shift is 0. So there we have 2 pieces of information for the x-axis and 2 for the y-axis. Now graph it. Well, there's a couple of ways to do this. One is you just start drawing the graph, and because of the period, it's going to go from 0 to 2 pi. Then this says, now shift those values to the right. So this one, you have to add pi over 2. And this one, you have to shift to the right by pi over 2. Now that I've done that, I need to redraw the graph. So 0 plus pi over 2 will be pi over 2. And then this one will be 2 pi plus pi over 2. Well, for 2 pi plus pi over 2, you could get a common denominator, which is going to be the 2, and this one multiply on the bottom by 2, multiply on the top by 2. So this is going to be 4 pi over 2 plus 1 more is 5 pi over 2. So this one is 1 pi over 2, this one's 5 pi over 2. In the middle would be 3 pi over 2. Okay, now we're done with the x information. The y information is pretty simple on this one. The amplitude is 1, so it's going to go up to 1 and down to -1. And there is no vertical shift, so these do not get shifted. And then draw the graph. So this one is sine. Sometimes to help me graph, I don't have a pencil right now, but I'll just lightly in pencil make a box. So draw a line straight across, draw a line straight across, and then divide it into 1, 2, 3, 4 rectangles. And then graph sine. So sine starts in the middle, it goes up, and then it hits the x-axis, it goes down to -1, and then it hits the x-axis. So there's my graph. And of course, I want to graph on the calculator and see. So go to y equals, erase that other one and just do the x minus pi over 2. Change the window to look like this window, which goes from pi over 2 to 3 pi over 2. Oops, sorry, that's supposed to say 5 pi over 2. I looked at the wrong one. And then that number is pi over 2. Actually, these are going, well, I guess I could do pi over 2. That'll work. That'll work. And then -1 to 1 for the y's. And you should see a graph that looks just like this. Although it's blue, but that's okay. It's still making the same graph. All right. Now, instead of drawing this and then having to redraw it because this would be getting a little bit sloppy, another way to do it instead of this is you go in order. First, do the period. And the period is saying that x is between 0 and 2 pi. So that takes care of this information from 0 to 2 pi. And then second, do the phase shift. So that means you have to add on pi over 2. So add pi over 2. And then this would say x is between pi over 2. And when you add these, that's this part over here, 5 pi over 2. And then doing this replaces having to draw this, and then having to start over. You can then just take this information, put it on the x-axis. Now onto an extremely important point. Example number 2. Y is equal to 4 times cosine, and then 2x minus pi over 2. So does it get shifted to the left or the right? You're right. It gets shifted to the right. By how much? Actually, it's pi over 4. Because when you go to figure out the phase shift, this has to say x minus something or x plus something. If there's a 2 in front of it, in front of the x, you'll have to factor it out. So the first thing we need to do is factor. So we'll have y equals 4. Now you cannot factor the 2 outside of the cosine. It has to stay inside the cosine function. So I'm going to need like brackets, and then factor out the 2, and then parenthesis. And when you factor 2 out of this, it leaves just x. Now there's 2 ways to do that, or at least 2 ways that I know of. You could try and think, well, what should I put right here so that when I distribute 2 times it, it gives me 2x. I know, I should put an x. Or another way to look at it is, by factoring out a 2, that's the same as dividing out a 2. So then these 2's will cancel, and you just have x. Well, you also need to do the same thing here, factor out a 2 or divide by 2, and it's going to leave minus pi over 4. So it gets shifted to the right by pi over 4. All right, now collect all of that information. Here's the x information, here's the y information. First of all, the period. So for cosine, its original period is 2 pi, and then you need to divide by this number. So divide by 2. The 2's will cancel, it just leaves pi. Then for the phase shift, or the horizontal shift, that's going to be, you could just write positive pi over 4, or you could emphasize by saying it's going to move to the right. For this one, the amplitude is given by the number in front, so that's 4. And then for the horizontal shift, so that would be like if it said plus 11, or if it said 11 plus 4 cosine, that would be the horizontal shift. For this one, it's 0. Okay, so I'm going to use this method. First of all, do the period. So that means that x is between 0 and pi. Number 2, do the phase shift. So add pi over 4 and add pi over 4. So this side is going to be pi over 4. So x is between pi over 4 and what? Well, if this was $1 plus $0.25, that would be $1.25, which is the same as 5 quarters. This is going to be 5 quarters of pi. So on the x-axis, we're going from pi over 4 to 5 pi over 4. So that's 1 pi over 4, and that's 5 pi over 4. In the middle of a 1 and a 5 is a 3. So 3 pi over 4 is in the middle. Then move on to number 3. The amplitude means that it goes from -4 to +4. And if there was a horizontal shift, I would do that as step 4. Now what are we graphing? We are graphing cosine. So you don't have to do this part, but sometimes it helps if you make a little rectangular box that the graph is going to go inside. Okay, then draw cosine. So cosine starts at the top, it goes down to the bottom, and then it goes back up to the top. So now use the graphing calculator, and when you use the graphing calculator, make sure you graph the original problem exactly as it was before you did anything to it. So let's see, y equals, let me clear out this one, and then this one is 4 cosine 2x minus pi over 2 was the original problem. And then make the window look just like this. So from pi divided by 4 to 5 pi divided by 4. And I'm going to make this pi over 4s, so it's going to go over by 1/4 pi each time. And then -4 to +4, and the graph looks just like mine. Good job, calculator. You're rocking it. Way to go, buddy. Then on to example number 3. How about y equals 1 minus sine, and then it's x over 2 plus pi over 3. This has a 1/2 that's being multiplied with the x. So I need to factor that out. That is the first thing. So it's going to be sine, and then put brackets, factor out a 1/2, and then what does it leave? So for this term, it leaves just x plus, and the plus means it's going to be shifted to the left, but by how much? Well, this I divided by a 1/2 in order to get rid of this division by 2. So for this one, I also have to divide by 1/2. Well, dividing by a 1/2 is the same thing as multiplying by 2. And that way these 2's will cancel, it gives you just the x. And this will be 2 pi over 3. Okay, so here is the x information. Here's the y information. First of all, the period. So whatever number's in front, you take the absolute value, and that's going to be, oh, sorry, I was thinking of the y. Hold on. Sorry. So the period is going to be, first of all, 2 pi, and then divided by this number. So divided by a 1/2. And when you divide by a fraction, you need to invert and multiply by 2 over 1, which means it's going to be 4 pi. And then for the phase shift, so you could either say negative 2 pi over 3, or you could say 2 pi over 3 to the left, because that's a plus, so that actually makes it go to the left. Then for the y information, the amplitude, so this is the part I was trying to skip ahead to, the amplitude is the absolute value of this number right here sitting in front of sine. So the number in front of sine is a -1, the absolute value will be 1. And then this one does have a vertical shift. You know what I just realized? Not that it's going to change anything, but right here I picked the wrong word. Horizontal is supposed to say vertical. But it was 0 anyway, so it doesn't change it. I just should have said vertical. Okay, so for vertical, this one has a vertical shift of 1. So number 1, start with period. So that means that x is going to be between 0 and 4 pi. Now go to the left. So subtract 2 pi over 3 and subtract 2 pi over 3. So this will be negative 2 pi over 3. And then this will be 4 pi minus 2 pi over 3. The common denominator would be 3. So this needs to be multiplied by 3 over 3. That makes it 12 pi over 3 minus 2 pi over 3. That equals 10 pi over 3. Okay, we're done with the x information. Now for the y information. So because of the amplitude, y would range between -1 and 1. And then this is shifting it up, so add 1 and add 1. So that means that y is between 0 and 2. Now draw that. So it's going to go from -2 pi over 3 to a positive 10 pi over 3. And what's in between a -2 and a positive 10? So I know it's pi over 3, and I know it's pi over 3, but in between a 10 and a -2, so you could just take a -2 plus a 10, average them. So add them up and divide by 2, equals 4. So right here in the middle, yep, that looks like the middle, is 4, and then they're both pi over 3, so this must be 4 pi over 3. And then the y values are going to go from 0 to 2. And then I like to sketch this. So it needs to be inside of this rectangle. And right in the middle of 0 on the y-axis, between 0 and 2, is a 1. So then just draw lightly a line like this. Okay, so now we're supposed to graph sine. And sine usually starts in the middle and then goes up. But because of the negative, that's going to invert it. So that means it's going to start in the middle and then go down first. And then by the time it gets to the middle of the box, it hits right in the center. Then it goes up to a height of 2, and then it goes back to the middle of the box. And that should be it. So like I said, when you graph these, graph the original problem. So that's going to be y equals 1 minus sine, and then it had x over 2 plus pi over 3. And then make the window look like this. So it needs to go from -2 pi over 3 to 4 pi over 3. And these could be pi divided by 3. That part right there is not extremely important, the scale. The y values from 0 to 2. And then it should look like the inverted sine graph. It goes down first, and Houston, we have a problem, because that is not the whole graph. So did I type this right? -2 pi over 3, that's the same, 10 pi over 3. Oh, that's not what I had before. So I must have been busy thinking about something, where the tick marks are, my speech about that, and I accidentally did not type that correctly. You know what? That is actually a good lesson, because that's what should happen, is sometimes the graph doesn't look right, and then you have to go, hey, what happened? I didn't type that one in correctly. Now that I did, I've got the whole graph. Now, while I have your attention, there's just one more that I want to do. And that is basically, what if you were given the graph, then work backwards, and what was the function? So here's the graph. So what was the function that created that? So first of all, for the x information. So this looks like one full cycle of sine. So I'm pretty sure that it's the sine graph. The period goes from 0 to 1, so the period is equal to 1. Now, we also have the formula that in order to find period, you go 2 pi divided by the number that's in front of x. Just like we did right here. 2 pi divided by the half. So that number is quite often called b. So 2 pi, somebody did the formula 2 pi divided by b, and they got the answer 1. So then you could cross multiply or multiply both sides by b, and it's going to say b was equal to a 2 pi. Now as far as shifting left or shifting right, it looks like it was not shifted. So we've got the phase shift is 0. Then onto the y information. So if you draw a horizontal line through the middle of the graph, then go from the middle to the top, and then that is the amplitude. So the amplitude is 1. And then for the vertical shift. Well, when you draw this horizontal red line through the middle of the graph, wherever that is, that's the vertical shift. And so I could just say the positive number 2, or I could say 2 up. That's like the generic version of 7-Up. They couldn't afford to have all 7 ingredients. Oh, I'm not supposed to graph it. I already graphed it. I was so busy making up cool jokes that I got distracted. All right. Anyway, so y equals. So amplitude would go in front, so it's going to be 1 times the sine. Now the b was a 2 pi, so that's the number that is in front of x. And because the phase shift is 0, it's going to be plus 0 or minus 0. So that's actually not going to change it. If you do have a phase shift, then make sure that you put parentheses like that. And then 2 up, you could either put that 2 plus right here, or you could put it right here. And now let's see if I got it right. So I got 1 times sine 2 pi x, and minus 0 or plus 0 is not going to change it, so I don't really have to put that, and then plus 2. And finally, x is going from 0 to 1. I'm going to change that part to just 1. The y value is going from 1 to 3, and then I should see this graph right here. So it starts in the middle, goes to the top, good. Then it goes down, hits the bottom, and then it finishes. So that is the function that created that graph.